I'm gonna record. We ended with that first row of that table, right? Okay, I'm gonna give us another system, and then we're gonna tell how many solutions there will be. Do you want to start by graphing it? Or looking at the... Audrey, can you take your coat off? So how do we know? So we said if two lines have the same slope and a different y-intercept, that they were parallel, which means they intersect, which means the system has no solutions, right? And if we got down to a point where we got something like 12 equals 4, then it's no solution because that's not true, because there were no variables left. So how do we want to graph this first, look at the slopes and y-intercepts? What do we want to do? Michelle, what do you want to do? That sounds like a great idea. The pink one's easy. Y equals 2x. Okay, so you want to go ahead and graph it? Sure. If we are graphing that, we're just estimating, right? We don't exactly know. Will the y-intercept be up here or down here? Up. Will the line go like this or like this? Like this? Okay, so just as long as we have a line with a positive slope, that looks like that looks okay, yeah? Okay, the other one to put into slope-intercept form, 3y equals negative 2x plus 4. Right? So what does y equal? Bless you. Wakey, wakey, just yell out the answer.
Negative 2/3 x plus 4/3.
Right? So are the slopes the same? No. What do you think that's going to mean for the graph? Okay, they're going to intersect at one point. So let's, so the y-intercept, we said that this was 8, right? The y-intercept of the blue one is 4/3. So would that be up here or down here? Down. And then what direction would the line go? It would go like this, right? Why isn't me? So it looks like they intersect at one point. And so what can you tell us about the slopes? What do we say about the slopes? They are Two options, same or different? The slopes are different. So in this case, we had a slope of 2 and negative 2/3. What about the y-intercepts? Okay, so in this case, they are different. Do you think, talk to your pods, do they always have to be different? Say it louder for the people in the back.
No, because they can intersect on the y-axis.
Yeah, the lines could intersect on the y-axis, so they could have the same y-intercept. So there's really no conclusion that we can draw just based on looking at y-intercepts. Does that make sense? So we had 4/3 and negative, or I'm sorry, an 8, but they could but I would say they are often different. Okay, how would you like to solve this system? We have them both solved for y, so we could take 2x plus 8 equals negative 2/3 x plus 4/3, but what's gross about that? Fractions, right? So what's another option? We could do elimination. Yeah, and we also could take this and plug it in here, but elimination works. Is that what we want to do? Okay, and because it's set up nicely for elimination from the original problem, because what's going to happen, do we have to multiply by anything? No, when we have 2x plus 3y equals 4 and negative 2x plus y equals 8, when we add those together, we get so y equals 3. Is that our answer? So then what do we do? Oh man, this is my last time teaching you until January. Come on, give me some like fire. Where? Which one do you want to do? Okay. Sorry, I heard her first. No negatives. Negatives are our second least favorite thing besides fractions. Oh, someone did say radicals. You don't like radicals, right? No. So x equals, I want to make this purple. X equals, what'd I do wrong? Oh, math is hard. See, this is why I need you guys to talk to me. 2x equals negative 5, x equals. So our ordered pair would be let's look at how we did on our drawing of our graph. It's not too bad, is it? Because negative, wouldn't that be in that quadrant? So at least could be better, could be worse, but I'm not mad about it. So this is what a system looks like graphically, how the slopes and y-intercepts are, and solving algebraically if there is one solution. Let's look at the graph. So we would put it into slope-intercept form. Which one do you want to do first, Justine? Okay, so we would get 3y equals negative 2x plus 4. Madeline, what are you typing over there? Okay. What does y equal?
Negative 2/3 x plus 4/5.
We already graphed this, didn't we? So we know the y-intercept's going to be above the x-axis. It's a negative slope, so it's going to look something like this. What does y equal for the pink one? Mm-hmm. Okay, so that y-intercept, how's it going to compare to the blue one? It's the same. The slope, how's it going to compare to the blue one? So the lines will lie on top of each other. So when we mix, what happens when we mix purple, pink, and blue? We get purple, right? So all points on the line so talk in your pods for a second. Can we describe the solution as all real numbers? That's my question to you to talk to your peeps about. Do all of the numbers describe the solution? All of the real numbers, do they describe the solution? Chloe, what'd you say?
I said that it's not described as all numbers because it's a line, so not all points, not all numbers lie on the line.
Not all points lie on the line. This point right here, that ordered pair would be made up of real numbers, right? Is it a solution to this system? No. So when you are describing a solution that has all the points, it's infinitely many solutions. The arrows indicate it goes up and up and up forever and down and down and down forever. So every point on that line would be a solution. Okay, so tell me about the slopes. Yep, because we had negative 2/3 and 2/3. Tell me about the y-intercepts. are the same. Are they always the same for infinitely many solutions? Yeah. If we think back to I realized yesterday I was calling it Rooster's coffee, but it's Roasters. It's so embarrassing. Originally, one of the stores they had different, when you graph the lines, they had different y-intercepts because one store was charging a one-time $10 fee. The other store was charging a one-time $8 fee. So the total cost was never going to be the same because the cost per cup was the same. The slope was the same. The y-intercept was different. So then Roasters decided to move their initial fee down to 8, so they had the same y-intercept and the same slope, so the total cost was always the same, right? How do you want to algebraically? I'm going to do it both ways just because I want you to see what it looks like algebraically both ways. Which one do you want to do first? Substitution, just take the pink and set it equal to the blue. Because they both are equal to y. What happens when we subtract the x values? Or we would add 2/3 x to both sides? What happens to those? They go away, so we end up with 4/3 equals 4/3. You also could subtract the 4/3 and say 0 equals 0. Is that a true statement? So when we end up no variables in a true statement, that's our algebraic indication of infinitely many solutions. And I just want to show you the elimination as well. So if I wanted to use elimination on this, what would I need to multiply by? Yeah, we could take, so we have, could take that and multiply by -2 and then just keep the pink one the same. When we multiply, that's -4x minus 6y equals -8. What happens to my left side? Four x minus 4x is 0. 6y minus 6y is 8 minus 8 is, so 0 equals 0. Is that true? Is that the same thing as saying this? Is 0 equals 0 the same thing as saying x equals 0? No. This is saying, so we can have either x or y equals 0. If there's a variable, it can be 0, but then if the number is 0 equals 0, then it would be infinitely many solutions. So we want to look at if these systems have one solution, no solution, or infinitely many. If there is one, we're going to solve and explain what the graph looks like. If there are 0 or infinitely many solutions, use what we know about slopes and x-intercepts or y-intercepts to explain. So if we have y equals 8x minus 3 and 2x plus y equals 1, go ahead and work in your pods on trying to come up with a answer of the number of solutions and then a explanation. So you don't have to you graph it. You can if that helps you to visually see it, but you do when you explain what it means.
So we need to figure out.
Did you guys, do you want me to work, the most people do substitution? Did you take 8x minus 3 and plug it into here? Okay. So do you guys all set them equal to each other or what? Okay. Like that? Did you get x equals 2/5? And then y what'd you get for y? Yep. So you got 2/5, 1/5. What does that tell us about so there, how many solutions are there? What does the graph look like? Yeah, the graphs. We can just say the lines. What about characteristics of the lines? Do we know anything about the slopes or y-intercept? So all you have to say is different slopes. This case does have different y-intercepts, so if you said that, that would be fine. But if you ended up with a y-intercept and you said different, if the y-intercept was where they intersect, and you said different y-intercepts, that could take points off. Does that make sense? So I maybe would just stop there for this one. So how do you want to tackle this one? Do you want to try and go through solving algebraically? Do you want to, one of them is in y equals mx plus b form, right? So we could get the other one into y equals mx plus b form and look at the slopes and y-intercepts. Or we could go ahead and solve. It's up to, what do we want to do? What do you want to do? Oh, they're not talking to me. No. Thanks. Okay, so we can take this one and put it into y equals mx plus b form. You're welcome. Negative 3y equals 15x plus 6. So y equals... Yeah, and that's probably the easiest way for this particular one because that's all you have to do, right? If you can recognize if you can then draw the conclusion of what that means. So, do you want to start by talking about the slopes and y-intercepts and then come to the conclusion? What do you want to do? Okay.
Is the 2 so negative 2 is supposed to be negative 6?
No, because 6 divided by negative 3 is negative 2.
Okay.
Right?
Yeah.
Tell me something about it. Yeah, same slope. What else? So the lines are parallel. We do need to reference the y-intercept here. Does that make sense? So the same slope and different y-intercept, that's what makes them parallel. So then the system has okay, in your pods, pretend you're Emma and Ella, read the next problem and see if you can come to a conclusion there. Well, it says a portion of the graph, so.
Ella's correct. It's Ella. And they have, don't you want your well? Oh, yeah.
Passive aggressive alpha well.
It's like stay well.
Michelle, was it Michelle that asked that? Did you ask that about the arrows? Michelle asked an important question, said, should we assume they're arrows? And because there is this word here, there's a portion of the graph of two linear functions shown. That means that we're only shown a piece of it, right? So because we're only shown a piece of it, we should assume that there are arrows. Why do you think she asked that? Why would she have asked that? Yeah, because looking at this portion, it doesn't look like they intersect. But if the lines keep going, they would intercept. Why? Why would they intersect? Yeah. They have different slopes, right? The lines are not parallel. So since the lines are not parallel, they will eventually intersect. I'm just going to write my version of this. Okay, I would like your input on how to tackle this one, because sometimes my way is not the way that makes the most sense to you. So yeah, what do you got?
I was just
Yeah. Why would I use Emma and Ella? His names are too close. That's why I usually use Miss Hilbert and Miss Littmer, so that. Okay, so we have this system. We want the system to have infinitely many solutions, right? And so algebraically, that looks like number equals number, and it's the same number. It also looks like the slopes are the same, the y-intercepts are the same. So I really genuinely want to know, like, what is your thoughts on how that we could find out that value of b? Yeah.
Since you have to multiply the top one times 3 to get like the same slope and the same y-intercept, but you also multiply 10 by 3 and get 30.
Yes. So if in order to make those, if those match, then they would have the same slopes and y-intercept. So if we multiply that by 3, we would get 9x minus 12y equals 30, right? So then that would make, because these are the same, b would have to equal 30. No? Are you good? Is that a reasonable, do we follow, do we need other, that's mostly the way that I did it. I might have made it too mathematical, so I'm glad that that was the way that you saw it, Tegan. Is today Thursday? No, it's Wednesday. Ugh, I'm a day ahead.